In this unit, we're going to get into a concept that is really at the very core of chemistry class, and it's really important that we understand this so we can make sense of our chemical reactions later on. So let's go ahead and dive in to the concept of the mole. Now, here's an outline of what we're going to cover in this video. So we'll start by just very simply defining what a mole is and what we'll be using it for, a short review on units of measurement. Again, we'll get into Avogadro's constant, which this will be one of the most important numbers we learn in this class. We'll really put that into perspective just to know how big that number is. We'll get into a very quick calculator tip so these problems don't trip you up when it comes down to just putting in the calculator. It makes your life a whole lot easier. And finally, we'll get into an example on how to solve these problems. Let's start on some very simple terms. We'll just say, what is a mole? And you probably already know this. It's just a mammal. It's a little furry creature, so no, we're done here, right? All's done, simple enough. But no, actually, for when we use it in chemistry, we use the word mole a little bit differently because a mole is actually a unit of measurement that we're using for different substances. Now, what we're measuring using the mole are atoms, ions, and molecules. Now, we've talked about their structure before. We know all about the atomic theory, and we also know that atoms are very, 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 very small, and it is really difficult to use something that is very small. If you were to go in a lab and you were to try to get just about 10 particles, 10 molecules, well, you'd be spending a lot of time and a lot of money to do it because it is very difficult to do, and you need very advanced equipment to do something like that. So now, using matter in that way is not really that useful. It's kind of like if you went to a beach and you try to count every single grain of sand. There's a lot of sand in the beach. The grains are very small, so you'll be counting for a very, very long time if you try to count every single grain. So instead, we scale up our measurements to something that is a little bit more useful, and that's where the mole comes in that we use in our chemistry labs. Let's review very quickly on what units of measurement are, what we use them for, and why they're useful. So we are already familiar with a lot of units of measurements. We use them every day, but we don't normally think about them in terms of, oh, I'm using these units to measure out this many things. The reason why the units of measurement are useful is that it changes how we can group things, how we relay information, we pass it on to another person, things like that. So if we look at this example on here where I have a dozen baseballs, I have labeled on here, but I could just as easily say that I have 12 baseballs or that I have 12 tennis balls. And again, I can use different names to say how many baseballs I have, but I'm not changing how many baseballs I have. I can say either 1 dozen or 12 baseballs. It's still the exact same information. It's the exact same amount. I've only changed the names of them. And so that's very important to understand that for these different units of measurements, we're using different names, but we're still using the same information, the same amount of stuff that we have. Another thing to consider is that some units of measurement have a specific use. There's usually a unit that goes along with it. So in the case of a ton, if I just tell you this 3-letter word, TON, immediately you should know that I'm talking about weight and I'm measuring 2,000 pounds when I'm talking about a ton. And sometimes it's more useful to think of it in terms of that way. So, maybe if you're measuring the weight of a vehicle, it's easy for me to say this is a 2-ton truck as opposed to saying that there's 1,000,000 milligrams in a truck of this size. That doesn't really make sense. But 2 tons, that's easy to wrap your head around that concept. Also, if we're talking about money, we can use the term of grand, and that 1 grand is just $1,000. So if you come to me and you tell me that you won a contest and the prize was 5 grand, well, right away, I know that you can lend me some money. I know you got a little bit to spare. And now when it comes to chemistry, when we're talking about moles, we're not talking about mammals. We're talking about specifically the number of particles, and we're actually talking about a very large number of particles. So let's go ahead and take a look at what that number is. Let's talk about this very special number that we use with the mole and where it came from. So it is called Avogadro's constant, and the reason we call it that is that it came from the work of the Italian scientist Amedeo Avogadro. Back in the early 1800s, he worked a lot with gases. He studied them very closely, and he came up with what came to be known as Avogadro's law. And that was the basis of the information that we used to set the standard to measure matter. Now, for matter, we're not really concerned how much it weighs or what type of matter it is. Sometimes we just want to know how many things there are or the number of particles. So remember that when we're talking about moles, we're really talking about how many pieces of something that we have. Now, the new unit that we'll be using is called moles. The full name of it is MOLES, but when it's written in a problem, the abbreviation is just dropping the E at the end, MOL. So make sure that you're able to pick that up and that you're able to recognize it. And now, finally, we get into the number that goes into it. And so 1 mole is really the same as saying that we have 6.02 times 10 to the 23rd number of particles. And now, notice that this is a number in scientific notation, and this 23rd exponent means that it is a very large number. And again, this is one of the most important numbers that we get into for this whole class. So make sure that you save it, you remember it, and if you ever hear the word mole, I want you to immediately think of this number, 6.02 times 10 to the 23rd number of particles. Dig a little bit deeper as to how big this number really is, because when you see it here in scientific notation, it really loses a lot of the magnitude of how big this number is. So if we have 6.02, again, that's just a little bit more than 6. It's really not that impressive, right? But it's that times 10 to the 23rd power that is really the game changer in this number. So if you were to write this out without the scientific notation, this is the number that you would get, and that is 602 with 21 zeros in front of it. Again, this is an extremely long number, and it represents a hexillion. So when we're talking about a mole, it's like we just counted out a hexillion things, right? When we talk about dozen, we're talking about 12 things. When we're talking about a mole, we're talking about a hexillion things. And again, this is still a really, really large number to wrap your head around. So instead of me trying to come up with good explanations, I figured I could show you these 2 videos from YouTube. They're really great, well done, and it's really useful to think about the mole in terms like these. So if you have a few minutes, just check these out. If you're having trouble understanding how big a mole is, I think this will really help put it into perspective. Before we get into a problem and seeing how to solve these problems, let's go over the calculator a little bit, because I don't want you to take the trouble of setting up your problems all the way just to drop it on putting it into the calculator. So we're using scientific notation for these extremely large numbers when we're counting the number of particles in a sample. And so now scientific notation is very easy to mess up on the calculator if you're not being careful. So I want to show you the most reliable way to put in your very large numbers into the calculator. And so we'll be using the E function of the calculator. Let me go ahead and show you what that is. So there's only 4 steps. The very first one is very simple, just enter the value. So if we're still working with that Avogadro's number, in the calculator you'll be putting in 6.02. In this next step, we're going to go through 2 keys, so pay attention on this one. All right, we need to press the second key. It's this big blue key, kind of sticks out on the calculator like a sore thumb, so it should be easy to find on this one. This will activate the secondary function of our second key that we're pressing, which is that's x to the -1, but really we're using the blue text option of it, which is EE. When you do that, it puts in this E symbol on your calculator screen, and that's important because the E actually represents scientific notation. It's the same as typing in times 10 to the something power, except that it takes those 3 keys and just puts them into a single symbol. And the good thing about this is that it doesn't worry about the order of operation, just that exponent is going to stick with the number that you put in. All right, so finally the last step, you're going to enter the exponent value. So again, in our case for the Avogadro's number, we're using 23. So when you put in this Avogadro's number into the calculator, this is what it looks like: 6.02, symbol E, and 23. And this all runs together. So if you do another calculation after this, if it's multiplication or division or addition, it's not going to be messed up by the order of operations, because that is by far the most common mistake that are made on these problems. So let's practice up on an example. And now this problem should look a little bit familiar to you because it's the same thing that we've been using for the conversions. Remember that for these, the names are different, but the process in this problem is still the same, I swear. If you really think about it, all these problems are the same, only the names are changing, the names and the numbers. So let's get into it. So it's the type of problem that you'll be seeing. So how many molecules are there? How many molecules of sodium chloride are present in 2.25 moles? So what we have to do here is that we need to look to the problem and find the information in it. So in this one, go straight for the number 2.25 moles. Make sure that you notice that, and you will be copying that down to start your problem. 2.25 moles, and you set up a table around that. This is what's going to start our conversions. Same process before. We're going to take the unit of moles, forget about the number, just focus on the unit, and transfer it over to the bottom right. So moles and moles in this way. Now remember, in this next section, we set up a conversion factor. We need something that is equivalent. Well, remember that we do have Avogadro's number, and again, this is one of the most important pieces of information that we have. So again, mole, I already have the unit set up at the bottom, so I'm going to look for my unit in the factor. Here it is, mole. What's the number that goes with it? 1. So copy that over. 1 mole in the bottom section. Now at the top, I need to set the other side of the equal sign. So I will just copy this whole thing, 6.02 times 10 to the 23rd power, number of particles. I have that set up. Now, when you go through this problem, it's set up all the way as far as we need to go. We're answering for molecules. Here I have it set up for particles. Remember, they're still the same thing. Now, the units that I've used so far, moles and moles. Top to bottom, these two will cancel out. And I'm left with particles, which doesn't cancel out with anything else in the problem. That's exactly what I want. Now, if we go over to the calculator, make sure that you're very careful about the way that you enter this one. So if you just take it step by step, you'll be entering 2.25 moles in the calculator, and it is being multiplied by 6.02, and again, instead of using times 10, I'll be using that E symbol key. Remember, there's 2 keys to go with that second and x negative 1. Gets you the E symbol, and then you put in the exponent, which is 23. After that, these two top numbers are multiplied together, and they're divided by the bottom numbers. In this case, divided by 1. You put this into the calculator, and if you've done it correctly, this is the answer you should be getting out. 1.35 times 10 to the 24th power number of particles. All right. And so if you're doing a different kind of problem, so say that you're starting with the number of molecules from your problem, and you're trying to take it to how many moles it has in it, it's still the same process, just this conversion factor, you'll flip it to where your particles cancels out with the units you started with. So again, it just comes down to making sure that the units cancel. This will tell you which number is on top. If 6.02 times 10 to the 23rd is on top or on the bottom, it comes down to what unit you started with. Alright, so that's just a very short section on that, just introducing the mole concept. In the next section, we'll be getting into the molar masses. We'll be adding grams into the mix, but again, it'll be still the same process. We're just going one step farther on it.